Ram Ram, hello all. So my name is Shivam, and today I'm going to discuss a very important topic, measure of variability. So I think in last class we discussed about measure of central tendency, and in measure of central tendency I talked about like a mean, median, mode, and what is the significance of mean and median over a data set. Okay, so if there is an extreme data or if there is an outlier, so median is less sensitive towards that, and mean is more sensitive towards that. Okay, so these are all the things we have discussed in the last session. Now, if I talk about a measure of variability, so a measure of variability, or you can say a dispersion, so it means what? It means so this kind of a thing, or the measure of variability is help you to create a kind of a picture in our mind. Okay, so we create a picture of in our mind that okay, so this is a kind of data we can have. Okay, and the simplest measure of a variation is a range. Okay, so this variability can be determined by using like two techniques. One is range, another one is like standard deviation or variance. Okay, now range is a very simple concept. I think every one of you must be aware about that. What is a range? So a range is nothing but it is a measurement, or it is just it is defined as a difference between the difference of largest and smallest value. Okay, so highest value minus lowest value. So this is the formula for find out a range. Okay, so a very simple idea. Okay, so suppose if someone asks you that or maybe if you are a bike rider, or if you're riding like a bike just in a normal way, so people may ask you that what is the range of your speed. Okay, so you can say, okay, so my speed ranges from you can so you always try to share your range like in some interval. Okay, so you say that I'm riding at a speed of 40 to 80, in speed between 40 to 80. Okay, so the range of your speed is nothing but a 40, because 80 minus 40 is equals to 40. So the range is very simple. And again, so the same thing, this is a kind of a dispersion or kind of a variability, which a variation which we can see in our data set. Now the actual variation or actual like a dispersion can be seen by variance. Okay, variance or standard deviation. Okay, now again the idea is pretty simple or pretty easy to understand. That variance means what? So how far your data set from a mean value. Okay, so how um, from a average value. So what is the spreadness, what is the dispersion of a data set? Okay, so your value how far your value from the mean value or from the average value, so that is what we call as a variance. Okay, or standard deviation. So deviation is again the same word. Okay, so deviation means how we deviate. Okay, so how much we deviate from the mean value, so that becomes a standard deviation. Okay, and the formula is again the same thing. So formula is again going to denote you the same thing. So if there is a population, so you are going to denote this with a sigma square, and this is going to be xi minus mu whole square divided by n. So n is the number of value inside a data set. Okay, so this is what we call a variance. So variance is nothing but a measurement, or so it is so how much your value is dispersed, or how or deviate from a mean value or from the average value. So that is what we call a variance, or you can say a standard deviation. So and standard deviation is what? So again in same formula. So suppose standard deviation is denoted by sigma. So this is what we call a variance. Okay, so this is variance, and now this is standard deviation. So standard deviation is denoted by a sigma. Okay, so standard deviation is nothing, just a square root of this value. Okay, so you can write in this way. So sigma of xi minus mu whole square divided by. Okay, so this is what we call a standard deviation. Okay, now if I take a very like a simple example. Okay, so if I take a very simple example of how we can calculate and what is the. Okay, so the main thing. Okay, so the main thing behind following all this thing is we want to check the significance. Okay, so this is what I think I already discussed with you, that I need to find out the significance. Okay, so suppose this is okay, and fine, we are not able to calculate this thing in a limited time. So that's why I take an example from a book. And so suppose these are your values. Okay, so 5, 9, 16, 17, and 18. So these are our values. And so if you try to find out the mean of these values, so the mean of this value is nothing but, so the total of this value is 65. And if you divide 65 by 5, so it becomes 13. So mean is 13. Now x minus mu, so 5 minus 13 is minus 8. Okay, so x minus mu whole square, and then so summation of x minus mu whole square divided by n. So 130 divided by 5 is 26. And if you try to find out the standard deviation, so it becomes 5.1. Okay, now this is a simple idea of variance and a standard deviation. Now the main thing which we need to understand is the significance. What is the significance of this standard deviation, or what is the significance of this variance or measure of dispersion? So there is a formula, there is a rule which is called empirical rule. Okay, so there is a rule which is called empirical rule. Now empirical rule has something to like say. Okay, so if you try to understand the empirical rule, or if you so, and this is also called a 68, 95, and 99 rule. So if you simply like try to write this thing on a Google, so you are able to see a thing that what does this exactly mean. And the rule of thumb in empirical rule is that the okay, so it tries to tell you the like percentage of values that within the range of within a given number of a standard deviation from a mean of a data, if data is normally distributed. Okay, so suppose if the data is normally distributed, so normally distributed is okay, so always remember that if the data is normally distributed, so it is a symmetric data. Okay, so symmetric data is always in a bell-shaped curve. Okay, so empirical rule states that if there is a mu plus minus 1 sigma, so it covers 68% of your data. Okay, and this is what 68, 95, 99.7 rule. Okay, so if we try to calculate mu plus minus 1 sigma, so it covers 68% of your whole data. Now if we try to calculate mu plus minus 2 sigma, so it tries to cover 95% of your whole data. And if you try to calculate mu plus minus 3 sigma, so it covers 99.7% of your whole data, which is almost almost 100%. Okay, so almost 100% of data it is trying to cover. Okay, so this is what your empirical rule states. Okay, now if you try to if I give you the picture. Okay, so if I give you a picture and so from picture you are able to understand it more easily. So this is what 68, 95, 99 rule, and you will get this picture very easily from the internet if you just try to write 68, 95, 99 rule in a Google. Okay, so it covers 68% of your data. Okay, so mu plus minus 1 standard deviation, then mu plus minus 2 standard deviation covers 68%, 95%, and this covers 99.7%, which is almost 100% of your data. Okay, so this is what empirical rule states about. Okay, now if you see like these values. Okay, so your mu is 13 and your standard deviation is 5. So mu plus minus standard deviation, if I take 1, now this is a dummy data set, but yeah, if you are able to you can relate this thing. Okay, so 13 plus minus 5.1, it is going to be what? So this is going to be a give so this is going to give you a value in between 7.9 is lesser than or equals to x is lesser than or equals to 18.1. Okay, so 68% data is going to cover in this region in between 7.9 to 18.1. Now if I take a mu plus minus 2 standard deviation, so I think in this case it is going to cover all your data set. Okay, so 5, so it becomes I think it is going to start from 2.8 something or 3, you can say, so 2.8 is lesser than or equals to x is lesser than or equals to, I think, 23.2. Okay, so in this reason it is going to cover 95% of the data. Definitely I can understand that you are not able to relate this thing with your data set which I have taken just now, but that is a dummy data set. Okay, so this is a case in this is a case in a real data set. Okay, so when you are trying to capture the real data, when you are trying to conduct some kind of a survey in a real data, in a real scenario, so this is what actually happened. Okay, now if there is like some data, okay, so now you are able to see this so these are the like some points. Okay, so which is out of this region, which is out of this 99.7% region also. So this data set, so these points are considered to be an outlier, so this data is considered to be an outlier. Okay, so this is the significance of variability or the variance and the standard deviation. And that is why so if someone asks you that, okay, so descriptive statistics is one thing, but if someone asks you that what is the sufficient statistics, okay, so if someone asks you that what are the things, what are the sufficient statistics, so sufficient statistics means what are all the techniques, so out of this like 5 or 6 techniques, what are those techniques through which are sufficient to describe your data. Okay, so which are sufficient enough, or which are like enough to describe your data. So you can always say that if I have so if you don't have any information about the data, so you if you don't have like a data, but if you have just a mean and standard deviation. So suppose somebody tells you, or so suppose if you know the mean and standard deviation of your data, so definitely in your mind you can create a picture of your data set. Okay, so this is how my data set may look like. Okay, so that is why these two terms, mean and standard deviation, is also termed as a sufficient statistics, because based on these two terms you are able to create a picture. If you are able to create a picture in your mind that this may be the possible value, or this may be the possible spreadness in my data set. Okay, so yes guys, so this is all about from this section, measure of variability. Okay, and maybe in next class I am going to discuss a probability or maybe a percentiles. So thank you so much guys, and if you have any query or any doubt regarding this session, so please put your query in a comment section. I will happy to answer you. Okay, so thank you so much. Ram ram, have a good day.